Hello everyone, in this video I will be talking about how I made my Rubik's Cube solving machine. This project was built for a university assignment. I will touch upon the mechanical construction, the code, and some of the problems and challenges that I faced. The machine isn't perfect, in fact it has a hard time finishing a full solve without any help. But I think that for what it is, it works quite well. Through a lot of tuning, I have gotten it to the point where it can make 90% of its moves correctly. But all that is needed for a failure is one unsuccessful move. However, it cost me no more than $30 and I think it was a good learning experience. One of the biggest lessons that I took to heart while doing this project is the right tool for the right job, or rather how hard your life can get when you don't have that tool. The most important thing when building any type of CNC machine is having precise and well-moving linear rails. However, these can get quite expensive, and with my low budget I couldn't afford them, so I set out to make my own. I succeeded to a point, but they are anything but perfect. To make them, I used a long metal piece which had a channel in it. This would be good for something to slide inside. Now, something that would fit inside that channel needed to be found. For that, these L-shaped metal pieces that are usually used to mount things on walls came in handy. However, they were too wide to fit inside the channel and needed to be sanded down. Some were sanded a bit too much because it was all done by hand, which resulted in some jerky movement of the rail. To keep the L-shaped metal pieces from jumping about too much, I put plastic sheets over them. I'm quite satisfied of how they turned out, considering they were made of what was essentially scrap metal. 4 rails were necessary for this project. Now that we have a system that can move, we need to find something to make it move. For this, I will have to go more into the types of solver you can make. The easiest and probably best choice are stepper motors, or any type of continuously rotating motor with positional control. One for each 6 sides of the cube. This results in a very fast and very efficient solve, but stepper motors, along with their drivers, can get pricey, especially when you need 6 of them. This was out of my budget, so I decided to use 6 servo motors instead. This choice changes the form of the solver very much, because once a servo is turned to its maximum position, it has to reset in order to turn again. 2 more powerful standard servos were used for driving the linear rails, and 4 mini servos for the actual turning of the cube. Their listed stall torque of 1.2 kilograms, while nothing impressive, should be enough to turn the Rubik's Cube. Why? Well, because I use a speed cube, a special type of Rubik's Cube designed to have a very fast and easy turning. This leading Star Warrior W was very cheap and it turned out to be pretty decent. All this cost me around $20, which is a good price. The whole system would sit on this piece of scrap wood that I found in my shed. It looked and felt sturdy enough to endure some drilling and scraping. The linear rails were mounted on the wood with hot glue, which is sturdy enough to keep the system from breaking, yet easy enough to take off if some adjustments needed to be made. And trust me, a lot of adjustment needed to be made. Next, the motors and the rails had to be connected. This was done with fishing wire and was the most tedious part of the whole build. One wire being too tight or too loose could send the machine into chaos, and the margins were very small. I had to tie and retie these lines at least 20 times. However, one advantage this system has over other similar solvers is that it only uses 2 motors to drive the rails. This way, they aren't individually addressable, but that really isn't necessary anyway. Mounting the motors that do the actual turning to the L-shaped pieces was done with some wood, a couple of screws and some hot glue. I won't go too much into it because it was rather simple. Same thing goes for the mounting of the camera. The motors hold the cube with nails which fit into holes that were drilled into the cube. These holes were drilled by hand and were very imprecise, so I had to make them big and then fill them up with epoxy sculpt to shape them in the correct dimensions. This was also quite a difficult task. And that's pretty much it for the mechanical construction. It's nothing impressive and it doesn't really work all that well, but it's good enough for what it's supposed to do. The electronics in this project are rather simple. I used the webcam that I had for the color recognition. I'm not sure how much it costs. To generate the signals for the motors, I use an Arduino Nano, to which I flashed the Uno bootloader. I also added 3 buttons and 2 LEDs. The buttons are used to grab and release the cube when the system is in manual mode, and there is one extra interrupt button which stops all turning and resets the system to its default position. This is in case a critical mistake happens, and they do happen. To power the whole thing, I used a 2 amp 5 volt phone charger. This should be more than enough to power the servos. I'm not sure how it handles the current spikes that happen when you use servos, but it seems to be doing alright for the time I've used it. For this project, I had to learn to solder, and my first attempts at making the circuit were hilarious failures. By the fourth one, I had some skill and managed to make it without shorting 5 volts to ground. What a success! All in all, without counting the webcam, these parts cost me around $4. The software has 4 main components: the Arduino code, the color recognition code, the solving algorithm, and finally the Arduino move generator. Everything is written in C++. To help understand some of the things that I'm about to talk about, I will go a bit into Rubik's Cube notation. To say which side of a cube needs to be turned, we use one of the 6 letters: U, F, R, L, D, and B. Each letter represents one side of the cube. U for up, F for front, and so on. A singular letter means to turn that side 90 degrees clockwise. A letter with an apostrophe next to it means to turn that side 90 degrees counterclockwise. A letter with a 2 next to it means to turn that side 180 degrees. Connecting these types of letters gives us algorithms that we can execute. For example, this is what is called an E-permutation. Now that we know how to read Rubik's Cube notation, we can go more into how it's used for the project. Before we can solve the cube, we first need to look and recognize all 6 sides of it. This is done with OpenCV, and it's a very crude and very simple implementation. There are 9 areas of interests which the program looks at and gives out their main color. This is then fed into an array of colors which are given to the algorithm which solves the cube. The algorithm is an implementation of the Kotsiemba solving algorithm, written by Flatland. After the algorithm gives its output, we have to translate these human moves into moves that the machine can make. Because the motor only has access to 4 sides at any given time, instead of the 6 that the algorithm assumes you have, we have to implement rotations and side states. A 20-move human solution thus turns into 60 to 80 machine moves. This is the piece of the code that does this job. Communicating with the Arduino serial was done with a serial port class, which I found on the internet. And that is basically everything. As you can see, the code and the construction is not all that complex. However, a lot of improvements can be made, and every solve there are at least 1 to 2 mistakes which I have to correct by hand, otherwise the whole system fails. This project was fun and challenging, and I would love to do it with a bigger budget and better tools, maybe in the future. Thank you for watching, and goodbye.